Hi everyone, let's solve this problem odd even linked list. The problem statement says we are given a single linked list, group all the odd nodes together followed by even nodes. So we have to do it in place and it should run in order 1 space complexity and order n nodes time complexity. So let's see an example. For example, this 1, 2, 3, 4, 5, right? First we pick the odd positions values, which is 1, 3, 5 connected to 2 and 4. So for example, in this case 2, 1, 3, 5, 6, 4, 7. First pick odd values, which is like odd 2, 3, 6, 7. We are looking at positions, not the values, right? So then 1, 5, 4. So we connect 2, 3, 6, 7 with 1, 5, 4. So how can we do it? Let's start with the first intuitive algorithm. What we say is let's build two lists. One is the even list, another one is the odd list. And once I'm done, all I need to do is I need to point the odd guys tails next to evens start, right? So let's jump to the code. I think things will get more sense once I'll write the code, and let's prepare the setup how we'll do that. So because I don't know what I need to build, right? So let's create few guard nodes. So guys, this is like the similar problem we solved when we were solving this problem partition list, where we were asked to, we are given a linked list and a value x. We need to partition it in such a way all the values less than x comes before greater than or equal to x. So we had these two nodes, right? Two guards, lt and gt guards, less than greater than guard, and had this less than greater than writers, and we were iterating the list. Whenever we were finding, okay, if its value is less than x, we are putting it in less than, otherwise we were putting it in gt, right? So similarly we have to do it in this way, but now it's not a less than x condition. We have to see if it's a even node or odd node. Let's jump to the code. I say, okay, if node head, which is edge case, right? I say, okay, return none. Otherwise all I say is I have my odd guard, which is list node at -1, right? And I have my even guard, which is at list node -1, right? And now I will have my even and odd writer also, right? So I have my even writer, which is at even guard, and similarly odd writer will be at odd guard. So once I have this setup, all I need to do is let's get the access to the index where I am right now, right? So I say, okay, I'll be at my first position. I start the head. I say, okay, if index mod 2 equals to 1, it means, okay, this was an even node, so I need to append it to my odd writer. I say, okay, odd writer dot next should point to head, and odd writer should become odd writer dot next, right? Otherwise I write even writer, the same thing, right? Should be at head, and my even writer will become even writer dot next, right? And I'm moving further, my head is moving and my index is also moving. Once I'm done, right, all I need to do is I need to point odds writers next, right? Odd writer dot next should end with what? It should end with evens start, which is even guard dot next, right? And my even list should be ended also, right? So my even, I have to close my even list. So my even writer dot next has to be none, right? So once I'm done, my even is finished, my odds next is pointing to even. All I need to return is return odd guard dot next, right? So I'm returning the start of the odd list. So let's see guys if it works. Let's submit it. Awesome, it does. So there is another approach also which is explained in the solution. Let's see that approach. Let's first remove this part. Okay, so they say there are a lot of pointers, setup and everything. So there's an easy way to do that. They say, okay, the intuition is we put all the odd nodes in a single list and even nodes in another, the way we did it, and then we link the even list tail to the odd list. So they say the ideal, okay, let's see the way they solve it. They say we have this linked list, right? 0, 1, 2, 3, 4, 5, and we need to keep track of the tails of both the lists, the even list tail, odd list tail, which we were tracking by these writers. But now all we need to do is these pointers will be used to track the traverse the linked list. This is okay. The algorithm will traverse the original linked list and put the odd nodes into the odd list, even nodes into the even list, and the iterator should be, so they say okay, to traverse a linked list we need at least one pointer as an iterator, right? But here the pointers will be odd and even. They not only serve as a tail pointer but also act as an iterator to the original list. So let's see the example how it's doing. So we say okay, my odd pointer is here, my even is here. Now these guys are the tail of odd list, right? Because the odd list is starting at 1 and the even list is starting at 2, right? And now in the next step, I don't know how it will happen, but in the next step the odd will point to this guy, right? Once the next point to 3, I have rewired it and now I am reaching at 3. And evens next, right? So evens next should point to 4 and it should reach here. So again my odd and even are pointing to the end of odd and even. So once I'm done, right, my odd will be pointing at 1 3 5 5, right? And even will be pointing at, in this case, null, right? And I just connect odds next to this. So how can we solve it? Like, let's try to dive deep into, like, how will iterate and everything. Let's see the underlying mathematics here, right? Because there are a lot of there's a possibility of making a mistake, right? So let's see the underlying math. So I call it like loosen the knitting pattern. So what has happened is we were having two threads and we knit a sweater, right? So for example, thread 1, thread 2, thread 1, thread 2, right? All we need to know is now we need to split this. We need to get this thread first, right? And then get this thread, right? And once I've done, the last of my this guy thread, like last of this thread, right, should connect to the start of this thread, right? So how, let's see the block diagram. I say okay, I have this, let's say two threads. One is a black thread, another one is a red thread, right? Black is pointing to the last of the thread, black thread, everything is black so far. And now black's next is pointing to red, right? And I need to fix it. How can I fix that? Okay, I will have next as a black thread, that is for sure, because I have to unknit it, right, or loosen it. So what I say is okay, my black's next should point to red's next, and then black should become that. So I did that, right? So I reach here. So again that constraint is met. Now everything is black and I'm pointing at the last of black, and then my red's next should point to black's next and should become that. So it became. So remember this, but see the idea here. We need to have one pointer next to red, otherwise everything is fixed, because there will be no node here and black's next is just pointing to red and we have to change the last thread only, right? So let's see what are the stopping criterias in both the cases when we have even and odd list. So when I will have my even list, right, so what will happen is I will be having odd thread, odd thread, odd thread, and I will have even thread in the end, and the last of odd is pointing to even, right? And its next will be pointing to null. So everything has been done. All I need to do is I just need to replace this guy. So my error condition will, my edge condition or stopping condition will be stop when you don't have anything, right? Which means you have fixed everything. And in the case of odd, I might have a odd list, odd pointer, even pointer, and its next is also odd, right? So once I'll fix that, my even will point here, none. So what has happened is I fixed everything odd, I fixed everything even, right? Every even has been fixed. But now odds next is pointing to null, which means I don't need to fix this guy but it's fine to point it to first pointer because we already have to, right? So, and even list is fixed entirely, its next is also pointing to null now. So the idea is either my even should be null, at that time I stop, otherwise evens next should be null, I'll stop at that point. So let's jump to the code. I think things will get more clear from that. So let's get rid of this. All I say is okay, I have my odd thread, right, which is at head, and my even thread which is at head dot next. So let's do one condition here also. I say okay, if not head or not head dot next, I have fixed everything and I return head only, right? Otherwise I have these guys, odd thread and even thread, and now I will use these two guys to iterate the list. What I say is okay, if I have my even thread, which means okay, there is something there which is this condition, okay, if I didn't reach here, otherwise I have fixed everything, and even thread dot next is also there, which means I didn't reach at this point yet, right? If I have reached, I'll just stop it. My evens next is also none. So what I do is I need to point the odd thread to the next odd thread. So how I'll do that? Let's see this. I say odds next should be evens next, right? And odd should become that guy. So let's do that. I say okay, odd thread dot next should become even thread dot next, and my odd thread will become odd thread dot next. And this same step we have to do with even thread. I say okay, even thread dot next now will become odd thread dot next, and my even thread became what? Even thread dot next. Sorry, even thread dot next. So I have set up this, so I just change this guy to here and my red guy to this guy, right? So once I'm done, all I need to say is okay, so my even is somewhere and its next is either null or it itself became null, right? So even I don't have to do anything, but my odd threads next has to point to start of the even list, but I don't have access to this. So let's save it. So I say okay, my start of even was at even thread, right? So if I have that, I just point it to start of the even, and all I return is I just need to return head. So let's see guys if it works. Okay, oh, well headed. Okay, okay, let's submit it. Cool, it works. See you guys in next video.